Hello everyone, welcome to Maratha Vidya Prasarak Samajas, KRT Arts, BH Commerce and AM Science, that is KTHM College, Nasik. Myself, Sampad Demse, working as Associate Professor, Department of Electronic Science. This is my third video lecture for subject Microcontroller Learners, Paper 2. Unit first consists of microcontroller architecture and topic for today's video lecture, timers and counters. This is the university syllabus for paper 2, microcontroller learnings. Unit first, microcontroller architecture, and we are going to focus on today's video lecture, timers and counters. So let us discuss timers and counters. The block diagram of microcontroller 8051 having the block, that is timer 0, T0 input, timer 1, T1 input. So this block included in 8051 microcontroller block diagram, and this work as timer as well as counter. So let us discuss in details timers and counters. 8051 timers and counters. The 8051 has two timers, timer 0 and timer 1, which can be used either as a timer to generate the time delay or as a counter to count the events. The 8051 has two timers, timer 0, timer 1. They can use either as a timer or counter to generate a delay or to count the events. Timer 0, timer 1, a 16-bit register. So it's wide, means 16 bits in wide. Timer 0, how this register is distributed, lower byte and higher byte, that we are going to discuss. D0 to D7, this is the lower byte of timer 0. D8 to D15, higher byte of timer 0. So since the 8051 has 8-bit architecture, that is internal architecture of 8051 is 8-bit, and each 16-bit register accessed by two separate register of lower byte TL and higher byte TH. So this is separated with lower byte and higher byte. Timer 0 register is a 16-bit register accessed by low byte and higher byte. The lower byte is referred as TL0, this one, and higher byte referred as TH, so this one. This register can be accessed like any other registers. This register microcontroller can access with TL0 and TH0, lower byte. Timer 1 register is also 16-bit register split into 2 bytes referred as TL1 and TH1, lower byte of timer 1, higher byte of timer 1. So this is the lower byte D0 to D7 and name as TL1, 8-bit. D0, D8 to D15, the higher byte of timer 1, and name as TH1. So the timer register may be used as a 16-bit or may be used as lower byte 8-bit, higher byte 8-bit. Now how this timer selected in different modes, timer 0 and timer 1. So that is decided by timer mode register T mod. This is the 8-bit register which is used by both timer 0 and timer 1 to set various timer modes. So this register is decide the timer 0, timer 1 used in which mode. In this T mod register, lower 4-bit are set aside the timer 0 and 4 bit upper 4 bit are set aside for timer 1, like this. So this is a format of T-mod register, and this format is divided like this. So D0 to D3, that 4 bit for timer 0, and D5 to D8, D4 to D7. So these bits are used for timer 1. So in this register M0, M1, bit mode selection, C/T bar, counter or timer selection, and gate is used to where the clock is applied for timer 0 and timer 1, either external or internal. So this D0 to D7, D0 to D7, the lower 4 bit is for timer 0 and upper 4 bit for timer 1. Now when gate is, so for timer 0 and timer 1, gate is common. So when gate is equal to 1, enable timer or counter only when the INT 0 INT pin activate. So that is external interrupt. And TR0 and TR1, timer 0's reset pins is set. So when gate is equal to 1. When gate is equal to 0, gate flag bit, enable timer counter when TR0 and TR1 is set. So now what is the use of C/T bar? Counter / timer bar. When C/T bar pin is equal to 1, flag is equal to 1, then counter gets selected. Means timer 0, timer 1 work as a counter. And when C/T bar is equal to 0, then timer 0 and timer 1 work as a timer to generate the delay. Now how the mode gets selected? The 8051 microcontrollers timer 0, timer 1 use in 4 different modes, and that is given by timer board select registers M0, M1 bits. When both bits M0 and M1 are 0, 0, timer 1 and timer 0 use as 13-bit timer mode. And when 0, 1, that is mode 1, 16-bit timer mode. 1, 0, mode 2, 8-bit auto reload mode. And 1, 1, that is mode 3, split mode. So these are the 4 different modes. In exam, the question asked on this topic like this: draw the format of T-mod register and explain each flag bit in details. Or what are the different types of modes of timer 0 and timer 1, how they get selected, like the question asked in exam. So let us discuss the modes bits in details. So M0, M1 are the mode select bits. There are 4 modes to operate the timers. The first one is mode 0. So in mode 0, 13-bit timer and 13-bit timer or counter, 8-bit for higher byte of timer 0 or timer 1, and 5 bits is for lower byte of timer 0 or timer 1. So this is operations 13-bit timer mode 0. So when it is 13-bit, 2 raised to 13, that means 8192 pulses can be count or delay can be generated by using mode 0. This means the maximum number of time can count without repeating is 2 raised to 13, that is equal to 8192. So the maximum allowed clock count value of timer register from 000H to 1FFH. So that is this much value we can store in timer 0 or timer 1 in mode 0. Mode 1 is a 16-bit timer. It is similar, the 16-bit timer or counter, and this THX cascade with TLX. So 16-bit will be there. In 16-bit, which means the timer operation complete the maximum clock pulses 65,535 clock pulses including 0. So the maximum allowed count value in timer register will be 000H to FFFH, that is 65,536. Mode 2, that is, this mode is a 8-bit auto reload mode. So this is the 10, then mode 2 occurs 8-bit auto reload mode. 8-bit timer or counter can be used like this TLX reload value with TXH, and each times TLX is overflow. The maximum timer operation complete with 256 clock pulses because 8-bit operation in mode 2. Mode 3, this mode is a split or timer mode. So in this, a separate 16-bit timer X into 8-bit timers, means we can use higher byte of timer 0 or 1 separately and lower byte of timer 0 or 1 separately. That is why it is named as split mode, which means the loading value in T0 timer 0 and automatically started with timer 1 T1. Let us discuss a simple examples related with T-mod registers. Find the time period of machine cycle in each case of the following crystal frequency of different 8051 based systems: 11.059, 2 MHz, 16 MHz and 20 MHz. So the machine cycle will be generated like this. Let us take the first crystal frequency, divide it by 12, so that gives us 921.6 kHz frequency. And this frequency, so machine cycle will be 1 upon that frequency, and that is 1.085 microsecond machine cycle generated for this crystal. If we take the next crystal with frequency is 16 MHz, so 16 by MHz divided by 12, 1.33 MHz. So machine cycle will be 1 upon this frequency, 1.33 MHz, so 0.75 microsecond machine cycle generated for 16 MHz crystal. If the crystal is having 20 MHz, 20 divided by 12, 1.66 MHz, so machine cycle will be 1 upon frequency 1.66, and that is 0.60 microsecond machine cycle generated. Now how we use our T-mod register in, or how the T-mod register select different timers in different modes. Find the value of T mod if we want to program timer 0 in mode 2. So timer 0 work as mode 2, that is 8-bit auto reload mode. For that, so T mod register will be like this. So this upper bit reserved for timer 1. We have to use timer 0. So all bits are 0, 0, 0. Let us discuss timer 0. So this 4-bit, lower 4-bit reserved for timer 0. So how it is? You see, the mode 2 means M0, M1 will be 1, 0. C oblique T bar will be 0 again, because C oblique T bar is equal to 0, timer mode. And we take the clock from internal, so this will be 0. So 0, 0. This will be 0, 0, 1, 0. That is timer 0 in mode 2. Okay. And C oblique T bar is equal to 0. XTL clock means source will be get is equal to 0 internal, and that will be controlled by start and stop bit methods, and these bits will be 0, 0. The 0, 2, so this 0 and this 2 value move in T mod register such that your timer 0 work in mode 2 by using instruction move T mod #0 to H. That will keeps the timer 0 in mode 2. Example 2, indicate which modes and which timers are selected for each of the following. If we are having the instruction like this, move T mod #01H, then the mode will be selected like this. Now see, the content will be 01H. 0 means 40 and 1 means 0001. So for this 01, the 16-bit timer mode, that is mode 1 is used. So we can write like this, 01. So T mod will select mode 1 and timer 0 selected. Similarly, there is MOV T mod #20H. Then this will select the timer 1. So this will be 2, this is 0. So 20, that means T mod will select timer 2, timer 1 in mode 2. If we use the instruction move T mod #1 to H, then both timer 0 and timer 1 get selected. So this 1 means 0001 and 2 means 0012. So that means this will select a timer 1 in mode 1, and this will select timer 2 in mode timer 0 in mode 2. So like this. T-con register is also very important. T-con register is a 8-bit register which contains timers and interrupt flags. So this lower nibble, that is 4-bit, bit 0 to bit 3, reserved for interrupt flag, and bit 4 to bit 7 reserved for timer flag. So like this. So this is a interrupt flag and this is timer flag. Bit 7, that is named as timer 1 overflow flag. So overflow flag, how it is? When this bit is equal to 1, timer 1 overflow occurs. Timer 1 goes to its maximum value, and when roll back to 0, then this bit will be selected. How it is, you see. So this is the content of timer 1 8-bit. Suppose TF will be 0. It is incremented as the clock comes by 1, and when the last count value comes EF, 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 E, then also TF will be 0, and this is a final value EF, 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 4 Fs, and when it roll over to 0, 0, 0, 0, your trap flag will be set. This is the timer overflow flag. TF is equal to 1. So this bit is reserved for timer 1 and overflow flag gets set. TR1 means timer 1 run control bits. When it is equal to 1, TR1 is equal to 1, timer 1 start. When it is equal to 0, timer 1 stop. Means start the delay or count these bits is very important. TF0, timer 0 overflow. It is like this, similar. When rollover occurs, means final value to first value, initial value, then this flag gets set to 1. When it is 1, timer 0 overflow occurs, and when it is equal to 0, the timer 0 overflow not occurs. So this is start and stop bit of timer 0. Then the remaining 4 bits of TCON register, timer control register, is for external interrupt 1, IE1. When it occurs, this bit will be 1. When not occurs, then this bit will be 0. Bit 2, IT1, external interrupt trigger, type selected. So when one external trigger comes and when it is 0, then INT1 pins activate. Bit 1, that is external interrupt 0 H trigger flag. When it is 1, external interrupt occurs, 0 occurs, INT0. And when it is equal to 0, external interrupt 0, proceed. Bit 0, IT0, external interrupt trigger type gets selected. When it is equal to 1, IT0 is 1. Interrupt occurs on falling edge of INT0, and when it is equal to 0, then interrupt occurs on low level INT0 pins. So this is about timer control registers. Let us discuss the modes in detail. Timer 0 how work as a 13-bit timer. So in 13-bit timer mode 0, this TMOD register is used M0 M1 bit like this. So this is the operation of mode 0. Operation is 13-bit timer. When M0 M1 both are 0 0, mode 0 selected, 13-bit timer oblique counter, 8-bit of TH and 5-bit in TL. X indicates 0, timer 0 or timer 1. So in this 13-bit, the count value will be 0 to D0 to D15, 0 to 8191. So this is the count value. 2 raised to 13. And the registers are used like this. So this is the lower byte of timer 0 or 1 work as prescaler. 5 bits we use. So this D0 to D4, 5 bits, remaining are not used. And the other value is loaded, that is 8-bit in 8-bit higher byte register of timer 0 or timer 1. So in mode 0, these are the steps executed by programmer to program the timer 0 13-bit timer mode. Let us discuss how this mode occurs, the characteristics of this mode. Load TMOD register value. TMOD is equal to in hexadecimal 00 for timer 0 or 1, that is 13-bit timer. So this is the TMOD register, lower nibble for timer 0, upper nibble for timer 1. Load the calculated value TH in this higher byte or timer register. Load the calculated value TLX in TL0 or TL1. Start the timer by using TCON register or TR bits. When it is equal to 1, then timer start, or we may use the instruction set bit TRX. Monitor the overflow, that is TF flag. Still it does not get set. Monitoring it. When it's set, then stop the timer, clear by using TRX bits, and we may use the instruction clear TRX. So this will be the stopping the timer. Clear timer TFX bit by using this TF is equal to 0, and repeat the process 1 and 7. So this 1 and 7 it is repeated again. So how this timer works in mode 0? So these are the pins, crystal pins. Internally clock will be taken or externally clock to be given. Then this TL, T0 and interrupt 0 will be activated. Now see, when we take the internal clock, the crystal frequency get divided by 12. So this is connected to a counter or timer. C oblique T bar is equal to 0 means the timer gets selected and internal clock gets selected from crystal. When C oblique T bar is equal to 1, then the clock will be taken from this. So how it is selected, you see. So this internal clock is provided to the counters. This counter is mode 0, 13-bit timer or counter. Now when this clock is provided to the gate, and when TRX is equal to 1, we start the timer or counter, then the switch is closed, and like this pulse are given to, clock are given to the timers. Okay, so this is the clock given to timers 0, and this timers goes increasing the values from 1 FFH, and when it reaches this value and goes to 00H, at that time this overflow flag gets set, TFX gets selected, and this mode occurs. In mode 1, a 16-bit timer mode, and in this mode the TMOD registers content will be like this: M0, M1, 01, mode 1 selected, 16-bit timer or counter, and lower byte and higher byte both are having 8 bits, 16-bit timer. So this is the timer 0 or timer 1, which used to count the values, that is 2 raised to 16, 65,536 different clocks. So lower byte and higher byte loaded in timer 0 or timer 1. So how this mode occurs? What is the characteristics of this mode? Load TMOD register value, that is 00H for the timer 0 or timer 1 in mode 1. So this is the calculate the TH value, calculate the TL value, start the timer, and monitor TF, that is overflow flag. And after that, when overflow occurs, then stop the timer, clear the timer overflow flag, and repeat the process. So again, how this mode occurs? The clock we take from the internally crystal divided by F by 12, C oblique T bar is equal to 0, and at that time the timer selected 1, then the counter selected. Now this switch is closed. Now pulse is given. When pulse is given to the counter It start the counting from 0 to 65,536 pulses, and when it reach to maximum value, that is EFFF, and roll over to 00H, then this flag get set. When it is set, then counter or timer stop the counting or delay generation. So this is the mode 1. Thank you for listening. If you have any questions, contact on my mail ID sampardemse57@gmail.com. My WhatsApp number 9860389302. Thank you.